Okay, now we're going to look at determining the equation of a line given a graph of the line. Okay, so first thing we do is determine the slope of the line using method 1 of tool number 1. So using the rise over the run, create a triangle on it. Okay, so if you're given the graph of the line, you can just pick a couple points and determine the slope from the rise and the run. Okay, and use the slope and one of the points on the line to determine the equation of the line, as in tool 5. Okay, so in the last tool, if you had the slope and some point, so you have m equals rise over run, okay, and you have the coordinates of that point, then you should be able to do as in the last tool to find the equation of the line from a point and the slope. Okay, if the line happens to go, you know the y-intercept, then if you know the slope and b, you just plug it into the formula y equals mx plus b. Okay, if the y-intercept is clear on the graph, then you can just sub the slope and y-intercept into y equals mx plus b. Okay. If the line is horizontal, then the slope is 0, and the equation is just y equals b, or y minus b equals 0. Okay, or y plus c equals 0 if you're thinking of standard form with the c in it. Okay, so y equals b is a horizontal line. There's no slope. And the only restriction on it is that y equals a certain value. Okay, so if you had, there's the axis, there's a horizontal line. Doesn't matter what x is, but y has to be the same value going across there, so y equals b. Okay. If the line is vertical, then the slope is infinite. It's undefined. Okay, and the equation of the line is just x equals a constant. So again, if you look at the graph of a vertical line here, we know that the x value in all these points along the line is the same. Let's call it k. And the y values don't matter. So x equals that constant is the equation of the line, or x plus c equals 0. Okay. So some examples here. How about this first one? Let's blow this up a little bit. Okay, so here's the graph. And the graph, we can see the x-intercept and the y-intercept, and we can draw a triangle on there to find the slope. Very nice. The rise is 2 and the run is 5. The line's going up, so the slope is m equals 2 over 5. Goes through -2 on the y-axis, so you know the y-intercept is -2. That's b. Okay, and you can just plug that into y equals mx plus b, slope-intercept form. Now putting in the other form, you're going to multiply both sides by 5, okay, to get rid of the fraction. And then rearrange using algebra, and you get 2x minus 5y minus 10 equals 0. Or 2x minus 5y minus 10 equals 0, that way. Okay? All right, so this next one, here is the graph for example 2. And you may want to look at this and then just pause it and see if you can do the rest. Okay, for this one, you got a y-intercept again. The run is 3, the rise is -5, so the slope is negative this time, goes down. Okay? So you got the slope, the y-intercept. There is the equation. Converting forms here. Going to multiply both sides of this by 3. Okay, just like that. Multiply the 3 in, get something nice, and use your equation solving method to bring 0 to one side, and you get the standard form. Next one. And here's a graph where you have an x-intercept and the y-intercept isn't clear. So there's another point that is clear. And you have to use those points. Okay? From the graph, you can get the slope. The rise is 3. The run is 5. Okay, it's going up. So the slope is 3 over 5. And you can use one of those 2 points, as in tool number 5, to get the equation of it. Okay? So the slope is 3 over 5, y equals 3 over 5x plus b. You're going to sub in 2, 0, or negative 3, negative 3. Those are the 2 points. 2, 0, negative 3, negative 3. Okay? I'm going to use 2, 0. So plugging in 2, 0, we've got this. 2 is for x, 0 is for y. Now you solve for b. Okay? And b is nicely negative 6 over 5. And the slope-intercept equation is 3 over 5x minus 6 over 5 equals y. Okay? Not nice to graph from that unless your graph is divided up into fifths of a unit. Okay, so every dash would be 1/5. Take 5 dashes to get to 1. Okay, converting to standard form. Here we are. We've seen this before. So we multiply both sides by 5, get rid of the fractions, rearrange till it's in standard form. Okay. Next one. Here's the graph. You might want to again pause it so you can try it. No points are on the axes at all that are clear, so you have to pick 2 points that might be clear. These two, so negative 3, 5, and 3, negative 2. It's a line that goes down. You can get the slope from that. The rise is negative 7. The run from here to here is 6. Okay. M equals negative 7 over 6. So now you're going to try this equation here and sub in one of these 2 points. I'm going to use 3, negative 2. Okay, by subbing it in, we get that b is not the easiest to calculate, but we get b equal to 3 over 2. In the end is a nice answer. Okay. And y equals negative 7, 6, x plus 3 over 2. Okay, so now you want to convert that to standard form. And it's the same way we've been doing all along. Going to multiply both sides by 6, because 2 is a factor of 6. Okay, so we just need 6, not 6 and 2. And get 6y equals negative 7x, and 6 times 3 over 2 is 9. Rearrange it, and we get the nice standard form. Okay. Here's a couple more. So here is a line that is horizontal. These ones are straightforward. Horizontal, y has to be negative 1, can't be anything else, doesn't matter what x is. Okay, slope is 0. So it's a horizontal line. Y equals negative 1, or y plus 1 is 0. Okay. And then we have the vertical line. Vertical line. In this one, x can't change. It's always 4. Y is anything. Okay, so in this one, x equals 4 will be the equation of this line. Okay, so it's a vertical line. Allows y to be anything. X can only be one number. Okay, in this case, it's 4. So x equals 4. Not either form. It's not slope-intercept or standard form, but you can convert that to standard. There is no slope-intercept form for this. Okay. that's it for determining equation of a line from a graph.